Assalamu alaikum friends, how are you? Today we will discuss about super efficient motors technical overview. Before starting the video, please subscribe our channel and press the bell icon for more updates. So we are going to start our video. Super efficient motors technical overview. Power scenario in the country caused for energy crisis management. Industrialization and growth in population is creating a void between demand and supply, and this void is deepening day by day. The generating cost is increasing day by day, and the power tariffs are on the rise. Unless the above crises are properly managed, power scenario will be bleak. Conversation of the energy is the call of the day. There is a capital investment that can repay many times its original value over the next 20 years. At the same time, it can improve equipment reliability. The investment is straightforward. Install electric motors having the highest electrical energy efficiency commensurate with your needs. Efficient motors pay for themselves in a few years or sometimes even a few months, after which they will continue to pile up savings worth many times their purchase cost for as long as they remain in service. First one, introduction. Until the energy crisis in the 1970s, most general purpose motors were designed to provide rated output and operating characteristics at responsible cost at reasonable cost period. Efficient operation was best a secondary consideration as energy crises began rising. However, manufacturers began promoting improved motors they called high efficiency and energy efficient, although the terms were not defined specifically at the time. Old style standard efficiency motors remain popular because they are generally cost less than the new models. Purchasing against were seldom inclined to spend a little more money up in front in order to save on energy cost later on. But today the story is entirely different. Looking at the power scenario in the country, there exists a huge gap between the demand and the supply, which is widening. The generating cost is increasing day by day, and power tariffs are on the rise. This is affecting the profitability of all the industries. Hence, it is a trend in the industry to look for the opportunities of cost reduction. The major cost components in any industry includes material, labor, and energy cost. Material and labor cost reduction has its own limitation, and manufacturer does not have a direct control many times, but the manufacturer himself can influence the energy cost through easy energy conservation measure and effective energy management. Point 2, motor utility segmentation. The figure of the motor purchases in 2003 to 2004 will give an idea of this potential. About 5 million motors, accounting to approximately 5 million kilowatt, we have been sold in 2003 to 4. These figures are as reported by IEEMA or approximated to round figures. The non-reporting members also account for an additional 3-4 mil kilowatt. Fractional HP motors account for over 85% of volume. These small motors are used primarily in domestic appliances and are lately and or immediate or intermediately loaded. As a result, there is a little potential for cost effective energy savings. Direct current DC motors have applications in the industrial sector. There are a few DC motors in service and most are being phased out in favor of alternating current AC motors with inverter direct systems. AC low tension or low voltage motors are used by all end user segments and represents largest market following fractional horsepower motors. Point say, what does energy efficiency mean? Electric motors are simply devices that convert electrical energy into mechanical energy. Like all electromechanical equipment, motors consume some extra energy in order to make the conversion. Efficiency is a measure of how much total energy a motor uses in relation to the rated power delivered to the shaft. Nameplate rating is based on output horsepower, which is fixed for continuous operating at full load. The amount of input power needed to produce rated horsepower will vary from motor to motor, with more efficient motor requiring less input wattage than less efficient models to produce the same output. Electrical energy input is measured in watts while output is given in horsepower. 1 horsepower is equivalent to 746 watts. There are several ways to express motor's efficiency, but the basic concept and the numerical result are the same. For example, efficiency percent equals 746 into horsepower output equal 100. Watts power input, watts output, efficiency percent, comma or percent and watt input or multi. The ratio describes efficiency in terms of what can be observed from outside the motor, but it does not say anything about what is going on inside the motor and on it's what's happening inside the makes one motor more or less efficient than other. For example, we can rewrite the equation as below or its equivalent. Efficiency comma percent equal watts output plus watts loses into 100%. Hope guys you have understand about the super efficient motors technical overview. Please subscribe our channel and press the bell icon for more updates. Thank you.